Yeah, I should have.
Let's do this problem. We're going to write the first three non-zero terms and the general term for cosine of x. So that should be pretty straightforward, right? What is cosine of x? Should be 1 minus x squared over 2 factorial, or just 2, plus x to the 4th over 4 factorial, or 24 if we want. And do they want the general term too? Yeah. So -1, what is it? -1 to the n x to the 2n over 2n factorial. First part of part A there, pretty straightforward. And then we're going to write the series for f of x. So what should our series for f of x look like? Should start with, when x is 0, -1/2. So we should have a -1/2 term. Which makes sense anyway, because when we do our -1 and we divide by our x squared, that's going to give us that -1/2. So there's our -1/2. Our next term should be, we'll take our x to the 4th and divide it by x squared. So that should just be x squared over 4 factorial. And then the next one should be minus x to the 4th over 6 factorial. Everybody good with the general, or not the general, but the first three non-zero terms?
Yes.
All right, and what did your general term come out to be? Should be -1, we'll say, to the n plus 1, because we've got to start with the negative. And then we'll have our x to the 2n, and our factorial should then become 2n plus 2 factorial. Everybody good with both of those? Let's see. They gave you 1 point for everything for cosine, 1 point for the general term there, and 1 point for the first three non-zero terms. Good? Okay.
Yeah, pretty good.
Great. Part B, we're going to use our series for f at x equals 0 to determine whether f has a relative, max, min, or neither at 0. So how did we go about doing that? We need to take the what do we need to do? We need to look at the value for f prime at 0, first off, to see if it's equal to 0. So how do we find f prime of 0? Yeah, all we have to do is take, not our first term, but our second term, our x squared over 4 factorial. It should just be the coefficient on that. So what is f prime of 0 equal to? It should be, it is f prime of 0 times x to the, oh, sorry, not that one. Our f prime of 0 should be what we would get from between the -1/2 and the x squared over 2 factorial. Right, because this would be f double prime to give us our x squared. So f prime of 0 must be 0 for us to not have an x term in there. So we've got f prime of 0 equals 0. And then we can use the second derivative test if we want. So finding f double prime of 0. F double prime of 0 is what's it? X squared over 4 factorial. Yeah. So our f double prime of 0, well, normally this second term should be a, I mean, f double, we should be able to say that f double prime of 0 is positive. I mean, for sure, right? So we know that this is concave up, which tells us that this is a minimum. Everybody good with that? And they gave you 2 points for that. 1 for that and 1 for that. Good or no?
Good.
Great. Then we want to write the 5th degree Taylor polynomial for g around x equals 0. So that's going to start with a 1. And then our next term, we had a -1/2, so that'll become -1/2 x. And we had a x squared over 4 factorial, so that would become x cubed over 3 times 4 factorial. And what was the next one? X to the 5th over 5 times 6 factorial. Is that how many it wanted? 5th degree. So there's your 5th degree Taylor polynomial. Easy enough? That was worth 2 points. 1 if you had 2 correct terms, and 1 if you had 2 more correct terms. Any 2 is fine. And then part D, we've got the Taylor series for g at x equals 0 evaluated at x equals 1 is an alternating series with individual terms that decrease in absolute value to 0. Use the 3rd degree Taylor polynomial for g about x equals 0 to estimate the value of g of 1. All right, so we'll do that first. We want to find g of 1 using the 3rd degree Taylor polynomial. So what does that give us? 1 minus half plus 1 over 3 times 4 factorial. Using our 3rd degree Taylor polynomial. What does that come out to be? 1 minus half is a half plus, what is that? That's 24, it's 70 seconds, so 37 70 seconds. Good with that, yeah? And then the second part of it was probably what is the area? Explain why this estimate differs from the actual value of g of 1 by less than 1. So we would say by the alternating series error bound, the error is less than the absolute value of 1 to the 5th over 5 times 6 factorial, the next term, which is, I don't know what that comes out to be, but we'll say that it is for sure less than 1 over 6 factorial, which is what they wanted us to show that it was less. Right? Yes, we're going to multiply that denominator by another 5. That's clearly going to be a larger denominator and a smaller fraction overall. Good or no? People in Zoom, are you okay with that or no?
Good.
All right, what do you guys want to do? Do you want to do this last series one that we have, or move on to something else? People with the June 9th test, I know that's none of you, so I'm sure you 3 don't care. People in the Zoom that have the June 9th test, you want to do one more of these? Or we want to move on to something like area volume with polar, or just regular area and volume? What do you guys want to do?
Just one more and then polar coordinates.
All right, cool. And we'll still have some more that we can do also, because they're going to release, they're supposed to release the May 24th problems theoretically today. It said within 48 hours, and it's been almost 48 hours. So I was checking this morning. Cool. All right, let's do this one then. Last one, I'll give you guys 15 minutes. Ready to go. So for part A, finding the interval of convergence, what's our best way to do that? That's right. We'll do the limit as n approaches infinity and use the ratio test. -1 to the n plus 1 times 2x to the n plus 1 over n plus 1 minus 1 times n minus 1 over -1 to the n times 2x to the n, all inside absolute values, which will then give us the limit as n approaches infinity of -1s will all go away. 2x to the n plus 1 over 2x to the n is just 2x times n minus 1 over n. That limit is the absolute value of 2x. Everybody good with that? Make that less than 1. X is less than a half. Greater than negative a half is the interior of our interval of convergence. Then we have to check the endpoints. So at x equals negative a half, what did we have? We had a sum from 0 to infinity. It's negative 1 to the n 2x. So negative 1 to the, what, to the n? Yeah. Over n minus 1. And this one we could say negative 1 to the n and negative 1 to the n is negative 1 to the 2n, which is always going to be just 1 over n minus 1. And what do we know about 1 over n minus 1? Yeah, it diverges the series. Good? Everybody good there?
A quick question. When you substitute -1 in for 2x, is it because
Negative
you
1
prove
half.
the ratio?
Yeah, I'm putting negative 1 half in for x, which makes it negative 1 to the n.
Right. Okay, it's 2x. Okay, so it become -1. Okay.
Good? Yeah?
Yeah. Yeah.
Next one then becomes negative 1 to the n, and then 1 to the n this time, and n minus 1. And this is an alternating series. So this is going to converge, and we would note that it converges by the alternating series test because the absolute values of that are going down towards 0. They're decreasing, and it alternates. So our interval of convergence will be negative 1/2 to 1/2 inclusive only on the positive 1/2 side. Good?
Good.
Yeah. Okay. Now part B, what was part B asking us? Show that f of x is a solution to this differential equation where absolute value of x is less than r, where r is our radius of convergence from part A. So how are we going to go about doing this? Any thoughts? How'd this go? What did you guys do? Let's start with what is the series for y equals f of x? What is that series? What are the terms of that series? First term was, oh, this was starting at n equals 2. Oops. I was writing n equals 0 for all these. I didn't really look at that. N equals 2, 2, n equals 2. Should write that. Yeah. Anyway, what are the terms of our series starting at n equals 2? First term should be what? 2x squared. So 4x squared minus, what's the next one? Four x cubed over what? Oh, 8x cubed over 2. Oh, so it's minus 4x cubed. Yeah, minus 4x cubed. And what's the next one? Maybe we do one more. All right, and what's the general term? It was negative 1 to the n, 2x to the n, is that right? Over n minus 1. Yeah. So let's write then, what is the series for y prime? Because that's what we need, right? We need y prime, and we need to multiply it by x, and we need to subtract y from it. So let's find the y prime series. So what's y prime? It should be 8x minus 12x to the second plus 64 thirds x cubed. Yeah, and then the general term ought to be negative 1 to the n 2x to the n minus 1 over n minus 1. And then what else? This is u to the n minus 1, right? So that's the chain rule. So we're going to multiply this also by 2. Everybody good with that being your series for y prime? Good or no?
Good.
All right, so what is xy prime then? That's what it asks to start with, right? Xy prime? No, I've gone too far. Yeah, xy prime. So what is xy prime? That ought to be 8x squared minus 12x cubed plus 64 thirds x to the fourth plus negative 1 to the n. We've got 2 to the n minus 1 times 2. What is that? That ought to just be 2 to the n. Yeah. And then we've got x to the n minus 1, and we're multiplying that by x. Yeah. So x to the n over n minus 1. So that's xy prime. And then they wanted xy prime minus y. True? So if we're going to subtract y from that, how are we going to do that? I mean, just subtract them, right? I mean, 8x squared minus 4x squared is 4x squared. True. Negative 12x cubed minus negative 4x cubed is negative 12 minus negative 4. Um, 64 thirds x to the fourth minus 16 x to the fourth over 3 should be 64 minus 16 is what is it? 48. And so on. I'm not going to bother with our general term here. What is that didn't seem like it worked out properly, did it? Xy prime minus y. Oh, equals 4x squared over 1 plus 2x. Okay, so how can we show that that's equal to 4x squared over 1 plus 2x? Any thoughts on how we'll do that? If we take out a 4x squared from this, what are we left with? 1 minus plus 4x squared. Let's take out a 4x squared. Take a 4 out of 48, that's 12. 12 thirds is 4. Yeah. So if we take out the 4x squared, we're looking at 4x squared times 1 minus 2x plus 4x squared and so on. And what is 1 minus 2x plus 4x squared and so on? That is a geometric series, isn't it? Yeah. Where the common ratio is negative 2x. So this ought to be 4x squared times the first term, 1 over 1 minus negative 2x. And 1 minus negative 2x is 1 plus 2x, and that's 4x squared over 1 plus 2x. So that should come out to be what they said they wanted it to be, 4x squared over 1 plus 2x. And if our common ratio is negative 2x, that means that the interval of convergence, put that in absolute value, make it less than 1. Tells you that x is between negative 1/2 and 1/2, doesn't it? And that was worth 4 points. And the other part was worth 5 points. Good or no? That was a little bit complicated one, maybe. Probably one of the more difficult ones we've done. How do we feel about that?
Well, I wouldn't have gotten all 9 points, but I think I did well enough. Yeah.
Well enough. I'll take well enough. And the points were, let's see. I mean, you probably got all 5 for the first part. Most likely. The points for the second part were a series for y prime was a point, xy prime was a second point, xy prime minus y was a third point, and then stating it was geometric with this analysis at the end to get 4x squared over 1 plus 2x was the fourth point. Cool. So tomorrow, hopefully, we'll have all the free responses from May 24th, and then we can work on the series one from that too. But for now, let's look at another area of volume work. Unless you guys want to do something different. What do you think? I think we did that one last, maybe this one. This one's not polar. It's got related rates. It's got perimeter. It's got volume. How's this one look? Good? You guys can't see it, can you? How's this one look? Good? What do you think, Sean, since you're the only one answering in the Zoom?
Let's try it. And why not?
Yeah, why not? All right. Ready to go.